Mike Varian here, and I'm going to do a short introduction of Advantech's wireless sensing technologies for the Internet of Things. So the first thing we really want to frame up is we need to change our thinking a little bit when we talk IoT type systems versus control systems. That really changes the way we look at the hardware and the architecture as well. So we're all familiar with control systems, right? We're always scanning or polling these endpoints for data. Speed and determinism can be really important, especially when doing motion control, real-time type controls. And everything is typically wired and powered. That's very, very different than IoT systems. There, our endpoints tend to autonomously just publish data whenever they have something interesting to say or a pre-programmed interval, things like that. We tend to talk about very low speed, low bandwidth type devices. And we're talking wireless connections, and often these are going to be sleepy devices. They're battery powered, or they could be battery powered. So they're going to be asleep most of the time. Wake up, take a reading, make a decision on when and where to publish this data to. Typical applications for this are a little different than control as well. So it tends to be around versions of condition-based monitoring or asset utilization type monitoring. So everybody wants to reduce downtime. They want to get the best utilization out of their assets. They want to reduce service costs, reduce the number of truck rolls, things like that. So that's where wireless sensing can really come into play in these IoT type applications. Again, that's very different than a control system and how we use sensing there. So the technologies that Advantech has chosen that are really the leading technologies for these type applications are summarized here, and we're going to do a quick look into each one of them. So Wi-Fi, Smart Mesh, wireless sensing network, LoRaWAN has become very popular, and we're close to releasing in North America a cellular IoT sensing device as well, using the new Cat-M and Narrowband IoT technologies. Let's take a harder look at Wi-Fi. So this one is really the easiest because we're all so familiar with Wi-Fi, using it as consumers. So Wi-Fi is very much the highest bandwidth of all these technologies that we use for sensing. And it also is higher power, consumes more power to do so. So it's typically going to be an externally powered device. It's quite difficult to make a good battery powered Wi-Fi device. Battery powered meaning it's going to last many years on battery. Wi-Fi is also a little less robust than some of these other technologies when it comes to really challenging RF environments. So when I talk about a challenging RF environment, think about areas with lots of metal, which causing lots of reflections of signals and things like that. To combat that, what you really need is really good infrastructure, so a lot of access points to help illuminate any potential dark spots and things like that. Now, Advantech WISE products that use Wi-Fi recognize that can happen. So they actually log data in the background. So if the Wi-Fi connection is lost, once that connection is regained, it'll spew up that data that was been logged during that downtime. So Wi-Fi offers more bandwidth than the other technologies that we're looking at here. And it also consumes more power. So you're typically going to have externally powered Wi-Fi IoT devices. The next issue is Wi-Fi can be a little less robust in challenging RF environments. So you might need to use many access points. And by challenging RF environment, think of things with lots of metal surfaces reflecting signals, creating all these multipath interference, because that's our biggest challenge typically in RF. It's not so much the range or the distance, sort of thing. It's more about multipath interference and reflections of the signal. So Advantech WISE products, that we recognize that can be an issue with Wi-Fi. So all the Wi-Fi based products act as a data logger as well. So that means that they're going to keep logging data even if the Wi-Fi signal is lost. And then when that signal is regained, they'll send up that timestamped data, so no data will be lost. So LoRa technology has become really popular. And so LoRa is a licensed technology owned by a company called Semtech. And they've licensed this technology to many different chip and module manufacturers. So there's a lot of variety of parts available to build LoRa products. So terminology-wise, LoRa is the physical layer. And if you hear the term LoRaWAN, that describes the protocol stack on top of that. The overall architecture of LoRa is a point-to-multipoint technology. So that means we have a centrally located gateway, and that needs to be able to communicate to all the distributed nodes. So every node must be in range of that gateway. Now, LoRaWAN products are, if it is a LoRaWAN product, remember that describes the protocol as well as the physical layer. So they are actually interoperable between manufacturers. So that's a nice feature of LoRa. And what makes LoRa really famous is really its receive sensitivity. So it has the ability to receive signals that go far below the noise floor, and that gives us tremendous range. With our Advantech products, we can easily achieve several kilometers of range or even more. Another benefit of LoRa is it actually uses the 900 megahertz frequency band here in North America. So using a lower frequency like that, first it gets us away from all the clutter on 2.4 gig, but it also has inherently, just to the physics of it, has longer range and better penetration through obstacles and things. So those things all combine to make LoRa a very long range capable technology. So the next technology that we use is called Smart Mesh IP. So this is the technology that's used in our Advantech Wizard Mesh products. So this is a self-forming, self-healing mesh network where every node in the network is a routing and repeating node. So that gives us some interesting capabilities, and all this happens in the background, no configuration needed by the user. But the network itself manages itself to have both path diversity, meaning if a signal is blocked back to the gateway in one path, it'll find an alternate route through another neighbor node. But it's also frequency diverse. So it can actually move up and down within frequency bands within its 2.4 gig range and avoid that multipath interference. And it can accomplish that autonomously throughout the network. So this makes this really our most robust wireless technology for really difficult RF environments. Now it is still a gateway-based architecture, so you're going to have a centrally based gateway, and then every node needs to be line of sight within two of its neighbor nodes, and that's how we build out a really robust mesh network. So the next technology is a cellular-based technology. So this is relatively new. There's two technologies that are being supported across the cellular ecosystem. One is called LTE Category M, sometimes referred to as M1. And then the other one is NB-IoT, which stands for Narrowband IoT. So these technologies were really developed specifically for low power, low bandwidth type markets. So that includes IoT, includes wearable devices, and think smart health type sensors and things like that. So the advantage of this, of the technology in general and compared to the other technologies, is that you don't have to provide the infrastructure, right? You don't need a gateway, you don't have to put up your towers, you're essentially renting that from your cellular carrier. So Advantech's first product using this technology, first sensing product using this technology, is in certification testing now and will be out mid-year in 2020. We do have a router product that uses CAD-M technology that is currently in mass production and becoming quite popular. CAD-M and narrowband require, they take more power than LoRa or Smart Mesh, for example, but they are very capable of being battery powered in low duty cycle type applications. And you're typically going to use this technology when you have a highly distributed, amount of assets out there, or maybe your assets are mobile or even just not fixed. So they might be in a different location day by day, that sort of thing. So think, smart cities, think agriculture, construction, temporary deployments, things like that. There's a lot of interesting applications where you could use cellular-based sensing technology. So here's a comparison, kind of a little cheat sheet, if you will, of the various Wi-Fi or various wireless technologies, listing what frequency bands they use, typical ranges, and sort of sampling rates you could expect to see using that technology. So how do you pick which one is best for you? Almost always the best place to start is really understanding the application itself. So you need to know, do they have power available? Are they expecting this to be self-powered, battery-powered, energy harvesting sort of thing? What kind of range do they need? And then what kind of signal bandwidth do they require? If somebody says that, geez, I need 10 samples a second, you're not going to do that over LoRa. You're not going to do that over mesh. You're going to choose Wi-Fi for something like that. But then, on the flip side, they say, geez, I'm monitoring tanks, remote tanks, and I'd like to get 4 readings a day, and these things are scattered all over 3 states. There you're not going to try to build out your own infrastructure. You're going to lean towards a cellular type solution. And then once you've figured out what the best fit wireless technology is, now you need to look at the type of sensors that it actually required. So we need to be sure that whatever sensor we're going to use matches the inputs available on our products using that wireless technology. And there's a lot of room for creativity there. There's a lot of ways to sense different things. So that might be a place where you need to get one of our application engineers on the phone with you, and we'll help you select the best way to monitor whatever the physical attribute that you're trying to discover. And then finally, don't be afraid to mix and match. These all use IoT type architectures, so they can all publish data up into single applications So there's a lot of applications where you might say, hey, I need some Wi-Fi because I have a couple of things that I want to get high update rates with. And I'm going to put those on the Wi-Fi network and let them publish data. But I also have some things that are really slow and spread out. So maybe I'm going to put a LoRaWAN gateway out there and sprinkle LoRa nodes out there as well. And all those things can feed together into a single application. So mixing and matching these technologies is becoming much more common, and people are getting a lot more used to that. It really all comes down to the fact that it's an IoT type architecture, meaning everything can publish data, and we just need to point it to the location where we want to collect that data. And then that application really doesn't care which technology was used to acquire the data. It just wants to receive it in an IoT type format, which is often maybe a RESTful interface or MQTT. So I hope that helps summarize Advantech's wireless sensing technologies and helps you figure out which one to use and for what application. As always, thank you for watching, and I will talk with you again soon.